Thank you. I'll add you right now.
All right.
All right. Well, I'm glad we're doing a joint meeting here, because these are the kind of things, trig identities, that you just need a lot of practice. A lot of practice. So go ahead and fill up that Jamboard, Micah, with some of your questions. I'm sure Mitchell already did with a bunch.
Yeah.
Right, Mitchell?
I got like 1 or 2 slides done. I'm just quickly doing them now.
Okay.
I got a bit
go ahead
delayed
and-
with my workout and stuff, so.
No problem. Go ahead and do that. And it's taking a second for some reason to load. I don't know why it's been doing this today. I'm gonna close it down and open it back up, see if that helps.
Hey Mitchell, are you doing the worksheet from the packet?
Yeah, I got them day 2 and 3 pulled up here.
Okay, cool. So we have the same work then.
Oh, perfect.
Perfect.
Great.
Yeah, I just screenshot them because the quality's better. So
Yeah.
Miss Brayband posts the packets online. So yeah,
And you
just fly
said you
through it
have a
with
bunch. You have a
snipping
bunch.
tool.
There we go. All right. So I'm gonna just show you guys how I do it. I don't know how your teachers do it. Do you guys have the same teacher?
No,
Okay.
Yeah, you don't have Brayband.
I do not.
Different teachers do it different ways. So I'm gonna show you the way I prefer to do it, and then if it doesn't make sense, I can do it the other way as well. But I just feel like this makes more sense. Here's what I do. I write the left side or the right side, whichever one. I start with one side. Okay. And then I write equals, and then I keep writing equals down the page. And then at the bottom of the page, I write what I want the other side to look like. Does that make sense?
Mm-hmm.
Yeah.
So I'm basically just working with the left side and changing it step by step until I get the right side, and then I'm done. That's how I prefer to do it. Okay.
Mm-hmm.
Some people
do,
some teachers do it that way, and some teachers just keep writing, they just write tan x, tan x, tan x, tan x, and then they write change it over here. To me, that just doesn't make as much sense. But it's whichever way is fine. If you want me to do it that way, I will. I prefer to do it this way, where I write the left side and then I change it until it turns into what the right side says. Make sense?
Mm-hmm.
Yeah.
All right.
That's actually what our teacher taught us, so that's perfect.
That is what she taught you?
Yeah.
Perfect. Okay. The key is that I can't change both of them. I shouldn't be changing this side and this side. Like if I wrote tan squared x here, I just keep, so here's the reason I don't like to write this all the way down here, is because if I say that this equals tan squared x already, it's like I'm already saying something that's not necessarily true. You know what I mean? Mm-hmm. I only want to write true statements. So I'm writing secant. So I'm going to go ahead and distribute this in first, right? I'm going to distribute that in. So I've got secant squared x minus secant x cosine x. You see that this equals this because all I did is distribute it. So this is a true statement. And this also equals the next thing I'm going to write, which is, well, what is secant x times cosine x?
Is that cotangent or just tangent?
Micah, do you know?
No.
All right, so here's some things that you have to kind of have memorized. You have to have your reciprocal identities. So the sine of x is equal to
1 over cosine.
The cosecant of x is equal to 1 over the sine of x. right?
Mm,
The secant of x is equal to 1 over cosine of x. And the cotangent of x is equal to 1 over the tangent of x. You have to have those memorized. And also the flip, right?
mm,
Sine would be equal to 1 over cosecant as well. Cosine would be equal to 1 over secant as well, right? I'm not going to write all
Okay.
those. You also have to have memorized all your sine cosine ones. So the other sine cosine would be that the tangent of x equals the sine x over cosine x. You got to have that memorized. And the cotangent of x equals cosine x over sine x. Got it?
mm.
Yeah.
You also have to have memorized the Pythagorean identities. The Pythagorean identities are that sine squared of x plus cosine squared of x equals 1. And the reason that's true, let's take a look. Remember the unit circle? What's the radius of the unit circle?
1.
Yeah.
Very good. It's 1. And if the radius is 1, do you remember what was this side right here? What was your x coordinate called? Remember we had x comma y. What was your x?
The cosine.
It was the cosine. So this is your cosine down here. And what was the y coordinate?
Your sine.
You remember that, Mitchell?
Yeah, it's your sine.
I'm sorry. Do you remember that,
Oh.
Micah?
Could you
You
like
get what I'm
repeat
saying?
that for me real quick?
Sure. So in my unit circle, if we look here, let me just pull in a big unit circle so you can understand what I'm talking about. I've got a really nice, pretty one that I made for you guys, just for this reason. So here's my unit circle. And notice on my unit circle, see how I've got like you see this triangle right here?
Yeah.
This side down here, the x coordinate, that right there
Oh, okay.
is
I got it now.
that which is your cosine, right?
Yeah.
So this is your cosine of x, and the y up here is your sine of
Sine.
x, right?
Okay.
That's your sine of x. So that's sine x. And then what do we say about the radius? What's the radius always equal?
1.
It equals 1. So what's Pythagorean's theorem say?
A squared plus B squared equals
A
C
squared, sine squared plus cosine squared equals
tangent
1 squared. And that's your formula right there. Sine squared plus cosine squared equals 1 squared. Make sense?
Yeah.
Mhm.
So that's what I'm trying to say to you. Okay. So there's my picture, and that helps you remember it. Sine squared plus cosine squared equals 1. Now, here's the cool thing. If I divide everything by sine squared, watch what I get. See how I'm dividing everything by sine squared? What's sine squared over sine squared?
1.
It's 1. What's cosine squared over sine squared?
Would that be tangent? Wait, no, that'd
It's
be
right here.
cotangent.
Tangent.
It's cotangent squared. Do you see it?
Mm.
And what's 1 over sine squared?
1 over sine squared, that would be cosine.
That would be cosecant
cosecant.
squared.
Ugh.
Do you understand?
Yeah.
Yeah.
All right. So do you see how you didn't even really have to memorize that? You could just create it by doing that.
Mm.
And you can do the same thing with dividing everything by cosine squared. If I divide everything by cosine squared, what am I going to get? What's sine squared divided by cosine squared?
That would be tangent.
It's tangent squared.
Well, tangent squared, yeah.
And what's cosine squared divided by cosine squared?
That just cancels out, so that's 1.
It's 1. And what's 1 over cosine squared?
That would be 1 over cosine squared. Oh, secant.
Do you understand what I just did?
Yeah.
Yeah.
Okay. So really the only thing you have to memorize is this one right here. And it's not really even memorizing it. It's thinking of your unit circle. So you really don't have to memorize anything, but you do have to use these all the time. So you might as well just write them down. Like on your piece of paper, it's kind of like the unit circle. Just go ahead and write it down so that you have all these. Just kind of create that right there. All of them that have signs in the bottom are related to each other, the cotangent and the cosecant. See how those are related to each other? And the ones that have cosine in the bottom are related to each other, which is the secant and the tangent. So see that blue one? That's my secant and my tangent. Okay. All right, so back to my problem. Well, oh, and by the way, each one of these things also gives you more formulas that you can create. Look at the blue one on the lower right. Because if I wanted, I could solve this for tangent squared, can't I?
Yeah.
Mhm.
If I solve it for tangent squared, that means I'm going to subtract 1, right, from
Mhm.
both sides. So it's secant squared x minus 1. So there's another formula. The yellow one, I could also solve this instead. I could solve it for tangent. So what would I do? Cotangent squared x equals what?
Cotangent squared.
Cosecant squared
Equals-
x minus 1.
Very good.
Yep.
You got it? And
Mhm.
same with this red one. If I wanted to solve this for sine or cosine, I could do that very easily. I could say sine squared x equals 1 minus cosine squared x, right? Or I could say cosine squared x equals 1 minus sine squared x. See how I just subtracted it from both sides?
Mhm.
Yeah.
So there's a ton of Pythagorean identities, but you can just kind of move them around however you need them to be. So why am I saying that? Well, look at what I have up here. This is, I'll even show the work. Secant is 1 over cosine of x, right? Times the cosine of x. Well, what's going to happen with these things?
They're gonna cancel out.
They're going to cancel. And so I'm going to get secant squared x minus 1. And wait, secant squared x minus 1. Look at down here. What's secant squared x minus 1 equal to?
Tangent squared x.
Tangent squared x. So I actually can just write that up here. I don't have to write it so far down. Tangent squared x. I can erase the rest of these things and boom, it looks like I knew exactly what I was doing. Did I do that too quick for you guys?
No,
No.
I got it.
You got it? Okay. So let's do the next one. I'm going to just duplicate this slide so that I've got all this stuff right here. And then I'm going to erase this stuff. And I'm going to move this over. All right, we're going to work on this one now. Okay. So remember, I start by writing the left side. Secant squared x cosecant squared x equals, and then at the bottom, I write secant squared x plus cosecant squared x. And I probably don't even need that much room, but just to be safe, I'm going to give myself all that room. So here's the trick with these. It's kind of like a puzzle. Do you see how these are being multiplied together?
Mhm.
Yeah.
But do you see how these are being added together?
Yeah.
Yeah.
How in the world do I go from multiplying the same two things together, or multiplying two things together is the same as adding the same two things together? What? That seems pretty unreasonable, doesn't it?
Mhm.
Yeah.
But it's probably true because they're saying it is. So what I have to do is I just have to come up. Well, I know I'm going to have to split these up somehow. I know I'm going to have to split them up. And what better way to split them up than with the Pythagorean identity? See what a Pythagorean identity has? It shows you that a squared trig function is equal to the sum or difference of two other numbers. So that's what I'm going to do. And just for fun, I'm going to choose, I don't know which one I should split up, but I'm going to choose to split up the cosecant. What's cosecant squared x equal? Look for it on the right. What does that equal?
Cosecant.
1 minus sine
Yeah.
squared x.
Cosecant, not cosine. You're looking
Oh,
at
1
cosine.
minus cosine squared x.
Still
Oh.
wrong.
1 plus
Look at the yellow one.
1 plus.
Do you see it?
Yeah.
It's 1 plus cotangent squared. So I write 1 plus cotangent squared x. Okay, good. All with me
Yeah.
how I did that?
Yeah.
All right, now just trust the process. You're like, well, shoot, I don't see how this is going to work. Well, just trust it. Now what should I do with secant squared?
Secant
Nothing?
squared, you're gonna go ahead and
How about distribute it in?
oh.
Look at keep an eye down at the finish line. I want them to be kind of separated, don't I?
Mhm.
So shouldn't I just distribute that in? Let's try it. Let's see what we get. I'm going to get secant squared x plus secant squared x cotangent squared x. Good?
Yeah.
Mhm.
Okay, now I'm still thinking, oh, crud, this is pretty close. But this doesn't quite look like this. But I'm hoping I can make this look like this.
Oh, I know what you're
How
gonna
can
do.
how can I make this look like this, Mitchell?
You're gonna divide out the secant. Well, the secant. You're gonna divide out the secants, I believe. So then it would just be cotangent squared x. And
Wait,
then
how am I dividing it? No. That would just put me back to here. I don't want to do that. I already have this where I want it to be.
yeah.
I
Oh,
want to make these things look like this. So here's the next trick. You ready? One of the main tricks that you use with trig identities is converting everything into sine and cosine. Converting everything into sine and cosine. So I'm going to put stars by all these things that convert into sine and cosine. Those convert to sine and cosine. Do you see that?
yeah.
So
Mhm.
what is secant? So what is secant? I'm going to keep this how it is, but instead of writing secant squared, what is secant squared equal to?
1 over cosine.
Yeah, it's 1 over cosine squared, right? You with me?
Yeah.
Yeah.
And what is cotangent squared?
That would be cosine x over sine x. Cosine x
Micah, you
squared.
got it?
Yeah, I'm following.
Okay, now why did I want to do that?
So you
Oh, the
it's-
cosine's gonna cancel.
Yeah, now the cosines cancel, right?
can.
So I get secant squared x plus these cancel, and I just get 1 over sine squared x. And what do you know? What's 1 over sine squared x?
Cosine.
Cosecant.
That's cosecant squared x. Done. You can even put a little check mark to say you're done, or a little box. It's like saying, see, I told you so. I did it. That proves it. Okay. Get that?
Yeah.
Yeah.
All right. Let's try these next ones. I'm just going to kind of go a little bit quicker now, but I'm always going to keep referring back to those things. Okay.
Okay.
So remember how you can, what you're going to do. I'm going to make my little cheat sheet down here. I'll just do it on the bottom. Whoops, didn't mean to do that. Here's my little cheat sheet. Ready? I got sine squared plus cosine squared equals 1. By the way, I write it like that, S and C. Got it?
Yeah.
Just makes it easier. I'm thinking of dividing everything. Well, here, let me write these here. Cosecant is 1 over sine. Secant is 1 over cosine. And tangent is sine over cosine. And cotangent is cosine over sine. Okay, so now I'm going to just think of dividing everything by cosine. If I divide everything, or by sine, if I divide everything, let's see, what did I use? Yellow before? I'll try to be consistent. I use yellow for dividing by sine. So when I divide by sine, I'm going to use yellow. So this is going to be 1 plus, if I divide cosine by sine, look over here, I get cotangent, right? So 1 plus cotangent squared equals 1 divided by sine, look for the sine on the bottom, is cosecant. You see how I did that?
Yep.
And then for the blue one, it was sine divided by cosine is tangent. So tan squared x plus 1 equals secant squared x. So there's my 3 formulas, and I'm not going to write all the different iterations of that. This is pretty much all you need, and you can mess around with them if you need more. Okay, so back up to problem number 3. Ready? Tangent squared theta minus tan squared theta sine squared theta equals, I want that to equal sine. Sine squared theta. I think I can do it in 5 steps. Let's hope so. If not, I just erase it and I make it longer. Okay. Kind of like name that tune. So the first step is I'm gonna now
Wait.
again
For this one, wouldn't tan minus tan, wouldn't that just equal 0?
no, you can't subtract those from each other because this is a factor in that.
Oh, you can't.
It's not a
it's
term.
multiplied. I see.
Yeah, it's being
Okay.
multiplied. But what I can do is I can factor it out. I can factor a tan out. When I factor it out, what's going to be left here when I factor a tangent squared out?
Would just be 1.
It would be 1. Do you get that, Micah?
Yeah.
And what's going to be left here when I factor a tan squared out?
Oh, just
Micah?
sine squared? Oh, sorry.
Yep, sine squared. You get that, Micah?
Not that last part, no.
So look at what I did. I factored this out of this term and this term.
Mhm.
So a 1 would be left here, and a sine squared theta would be left here.
Oh, okay.
Look at it, think about distributing it back in, and you'll see, oh yeah, that's the same thing. All right, now doesn't this look familiar to you?
Yeah.
Look down
Yep.
here and tell me what that equals. 1 minus sine squared,
Equals cosine squared.
it equals cosine squared. So this just equals cosine squared. Got it?
Mhm.
Yeah.
Now what does tangent equal?
Oh, it equals sine over
Cosine.
cosine.
It equals sine squared over cosine squared. And now what can happen with those?
They can
The
cancel
cosines
out.
cancel.
They can cancel out. And there's my answer, sine squared. Done. Okay.
Mhm.
All right. So following your nose. That's what I call it. Just kind of follow your nose. The more you do it, the better you'll get at it. But you might go one direction and realize, oh no, that didn't work. I got to start over. Usually I don't do that because I've done these problems so much that it's like a chess player. I can see like 5 steps ahead and I kind of think through it. You guys aren't going to be there yet. So don't get frustrated when I make it look easy. Just remember, it's just going to take some practice for you. Okay, so first step, cosecant x times cosine x plus sine x equals, and at the bottom, I want it to equal cotangent x plus 1. So what's the first thing I'm going to do?
Distribute.
Yep.
Good guess. I mean,
Oh.
not guess, but good suggestion. Good suggestion. Plus cosecant x sine x. Okay, now what should I do? What do you think, Mitchell?
Let's see. What I would do next is Wouldn't you want to get rid of Wouldn't you want to get rid of the secants? I mean cosecants?
By doing what?
You would do 1 over cosecant,
Not 1 over
I mean-
cosecant.
1 minus
One.
cosecant.
No, 1 over.
Oh.
Nope, it's not squared. 1 over what?
Oh,
Just a
1 over
cheat sheet on the
sine.
bottom. 1 over sine. Got it?
Yeah.
So that's 1 over sine. That's 1 over sine. I'm trying to do my changes in red so you can see it. So there's cosine plus sine. So I replaced cosecant with 1 over sine. Now what?
Oh, the sine, one of the sines cancel out.
And what do you get?
You're gonna get
1.
1 over sine. Oh wait, yeah.
You get
Cosine of
that?
x. Oh yeah, I see. Because it's 1 over sine x. Yep.
Because that canceled, like you said, so that leaves a 1, and this is just cosine over sine. Hey, what's
Yeah.
cosine over sine?
Cotangent.
Cotangent.
Hey, I'm done. There you go. Okay. Not so hard.
Yeah. Huh.
Good. More.
Yeah.
Give me more. The more you do these, honestly, they kind of become fun. I hate to say it. They really do. They kind of become fun. I'm not joking. If you get good at it, it's like a puzzle. So let's do our little cheat sheet at the bottom. So sine squared plus cosine squared equals 1. Divide everything by sine, I get 1 plus tangent squared x equals 1 over sine is cosecant squared x. See how I'm doing that? Divide everything by cosine, you get tangent squared plus 1 equals secant squared. And then these ones are, of course, the cosecant of x is 1 over sine x. Secant of x is 1 over cosine x. Tangent of x is sine over cosine. And cotangent of x equals cosine over sine. I'm really doing this for you, not for me, because I already kind of have them. Actually, I take that back. I always do this just so I don't have to think about it. I can just apply the rules, but I don't usually write these down here because I have those pretty clearly memorized in my head. Okay. So these are looking a little trickier. So I'm going to start with this side. And I'm going to try to make it look like that side. So let me point out something. This is one term. This is one big term, one big fraction. This is 2 terms. So I have to somehow break this into 2 terms by the end. Remember that, keep that in mind. Okay. So this is a trick that you would not know unless you saw it. And it's called multiplying by the conjugate. Say what? I'll show you. So I'm going to multiply this. I'm going to take that and multiply it by the conjugate of the bottom. Okay. Now I know you're saying right now, how the heck was I supposed to know to do that? Because you've seen it done many times. That's how you know. So this might be your first time seeing it, but just remember that's one of those tricks, one of those tools you should have in your tool belt, and you might want to pull that out when you see something like this and you're like, what? Whenever you see something like this, you can immediately think to yourself, oh, if I multiply it by the conjugate, what's going to happen when I multiply 1 and 1 together?
It's going to be 1.
I get 1. What's going to happen to me, my outside and my inside?
Are they going to cancel out?
Yeah.
They're going to cancel. And what's going to happen to this times this?
It's going to be 1.
it's going to be squared. No, it's going to be sine
just squared.
squared. Sine squared. Hey, doesn't that sound familiar to you?
Oh, yeah.
Sine squared. It's
Mhm.
going to give me one of these Pythagorean identities. Okay. So here's what I get. I get cosine of theta times 1 plus sine theta. Notice I'm not even multiplying that together yet. No need to quite yet. Over, remember what you said? It's 1 minus sine squared theta, right? Got
Yeah.
that? You good, Micah?
You got the 1 minus sine squared theta from distributing the denominator, right? Like
Yep.
rolling.
I multiply this out. Remember how that middle term went away?
Yeah.
So I just got 1 minus sine squared. It's really just this. This is the thing that I did. A squared or A plus B times A minus B
Mhm.
is equal to A squared minus B squared.
Okay.
These are just conjugates of each other.
Mhm.
It gets rid of your middle term. Your middle term goes away when you multiply it like that.
Gotcha.
Okay.
Okay.
So, and what is 1 minus sine squared?
1 minus sine squared is gonna be
Cosine
So I'm gonna
squared.
first distribute. I'm gonna distribute in the cosine on the top. And what's the bottom? What's 1 minus sine squared? Look at this little thing. If I subtracted 1
Cosine.
minus sine squared, I'm gonna get what?
cosine squared.
Cosine squared theta. Now I'm running out of space here. Running out of space. Am I going to be able to fit it in? Let's find out. Now I'm going to distribute this to both of those terms. I see something good here. What's cosine theta over cosine squared theta?
That would just be
It
1
would be
over
1
cosine.
over, it'd be 1
Cosine.
over cosine theta, right? And
Mhm.
Which is
what's,
secant theta.
which is secant theta. And what's cosine theta sine theta over cosine squared theta?
It would
What's
just
gonna,
make it sine over cosine, which is tangent theta.
you got it. So I might need one more little step here. Just to be nice. Here's my one more step. 1 over cosine theta plus sine theta over cosine theta equals secant theta plus tangent theta. Boom, done. So notice what I did. I started with this and I changed it until I got to that. So I proved this identity is true. Follow that?
Mhm.
Yep.
Good. All right. Go back and watch the video if you can't remember. Let's see if I can sneak number 8 in here. All right. First step, write the left side. Sine x over cosecant x plus cosine x over secant x equals, and I want it to equal 1 at the very bottom. So the first thing I'm going to do, notice I've got 2 terms here, and at the answer I have just 1 term. So somehow I've got to combine these together. And hey, how do I combine fractions together?
Denominator.
You get the LCD for this one, and then you just
This is dirty. I don't even have to do that. I could do that, but see, I'm a good chess player and I can see exactly what I need to do. You know why I can see it? Because this equals what?
that
Over
equals
sine
1
x.
over sine.
Yeah, and when I put it down here, what's that going to do?
Multiply
gonna-
by reciprocal.
It's going to multiply by the reciprocal, so it's going to give me sine squared, right?
Mhm.
And what's secant?
Cosine 1 over cosine.
And when I
which is gonna
put
give you
1 over
cosine squared.
cosine, it's going to become cosine squared. And what's sine squared plus cosine squared?
1.
1. So this is going to be pretty quick. So the first thing I'm going to do is write sine x over plus cosine x over, and I'm converting these things into 1 over sine x and 1 over cosine x. And then I'm flipping and multiplying. So I get sine squared x plus cosine squared x, and that just equals 1. That was easy. If you could see it. Now, there was another way to do it, probably. You could have done it a different way. By getting common denominators, it would just take you a lot longer.
Yeah,
that was the most.
It would have taken me a lot longer to get sine squared plus cosine squared in the long run.
Right. So you could have done it, like I said, a different way. And it would still have gotten you the right answer, but it would have taken you a much longer route to get it. So sometimes it pays off to just look at it and think about your different options. So see what I did? I looked at it and I thought, oh, wait, these things are kind of like reciprocals of each other. Oh, so that is going to be here and that's going to flip up to here, and same with this, and boom, done. So think like a chess game. Think steps in advance a little bit. Okay. All right. I'm going to try to do this without writing my cheat sheet at the bottom. You ready?
Yep.
Let's see if we can do it. So I've got sine x plus sine x cotangent squared x. So what do you think that's going to equal? What should I do first?
Well, it's got to equal at the very end. Cosecant x, first of all.
So what should I do first? Any ideas?
Do you want to factor out the sine?
Very good. Get that, Micah?
Yeah.
So factor out the sine, and what are you going to be left with if you factor out the sine?
1 plus cotangent squared.
Very good. Got it?
Mm-hmm.
And Micah, what's 1 plus cotangent squared? Let's write a cheat sheet.
Cosecant squared.
1 plus cotangent squared equals 1 over sine is cosecant squared x. And the other one was tangent squared x plus 1 equals secant squared x. What did you say it was?
Secant or cosecant squared x.
Yeah, it's cosecant squared. So this is going to be cosecant squared x. And this was sine x. Now what? We're almost there.
Would you?
You can change the cosecant into the 1 over sine.
Perfect. Like it.
Yeah.
Like it. 1 over sine squared x. And now what?
The signs cancel out.
And you have what?
1
over sine.
1 on the bottom, right?
Yep.
Mhm.
And what's 1 over sine x?
Cosecant.
Cosecant.
Cosecant x. You're done. Good?
Mm.
Yep.
You guys did that yourselves. Good job. All right, let's try this one. Secant squared over tangent. And we want it to equal secant cosecant. What should we do? Any ideas?
Don't you have to use decomposition on it?
Yeah, sine cosine, you mean?
Yeah.
Yep. And what's secant equal to?
1 over cosine.
Cosine.
Good. 1 over cosine. And what's tangent equal to?
Sine over cosine.
Good. Sine over cosine. So now what?
Multiply by the reciprocal.
Perfect.
Yeah.
So I'm going to write 1 over cosine squared x times cosine x over
1
sine x,
I mean, son, yeah. Oh, I
right?
see. Yeah.
Multiply by the reciprocal.
Yep.
And what happens now?
It's gonna turn into
Over
be 1
cosine
over cosine
squared
of
or
x and
x
then 1 over
plus
sine of
sine
x,
x.
which
Yep, you're both
equals
saying
secant
it.
and cosecant.
Yeah, perfect. Let's see if we get some challenging ones. Those were pretty easy. There are some more challenging ones that we're going to get into. I don't know if we're going to see them on this or not, but
I can pull
All
up
right.
a more challenging one.
you're welcome to. Let's just whip through these though, okay? I got about 15 minutes left. All right. I want that to equal -1 plus 2 cosine squared x. So the first thing I'm going to do is, do you see how my answer is in terms of cosine squared x?
Mhm.
So
Yeah.
I want to change this one, not this one. Okay. So I'm going to
Yeah.
write cosine squared x minus, and I'm going to change that. Notice I'm using parentheses. Remember what sine was? Remember we had
Oh yeah.
sine squared plus cosine squared equals 1, which means that sine
It'd be 1
squared is
minus.
1 minus cosine squared, right?
Yeah.
Mhm.
Now what do I do?
Well,
Do you see?
wouldn't you distribute next?
Yeah, do you see why I put parentheses around this?
Mhm.
That equals cosine squared x minus 1 plus cosine squared x. Now what?
So you would combine like terms, so the cosine, so it'd just be -1 plus 2 cosine x,
There you go.
and you're out.
2 cosine squared x.
Yeah.
Done. Good.
Mhm.
Number 4, sine theta plus cosine theta cotangent theta. So this is going to be probably starting with decomposition. I like that term. I forgot that that's what they use nowadays. Turn them into sines and cosines, right?
Mhm.
Yep.
So we've got sine theta plus cosine theta times, what's cotangent?
Cosine over sine.
Cosine theta over sine. Okay, this one's going to be a little bit more challenging. So this equals sine theta. Now notice what I'm doing here. I'm squaring it. I'm multiplying it by sine theta on the top and the bottom. Do you know why?
Hmm.
Kind of doing 2 steps at once a little bit. I can see there's a denominator here, and I want to get a common denominator. So I multiplied this by sines on the top and the bottom.
Okay.
Do you
Okay.
get that?
Mhm.
Yeah.
I'm just kind of doing 2 steps in one, kind of. You're allowed to do that. That's fine. That equals sine squared plus cosine squared all over sine. Yeah, I'm adding them. They have common denominators. See how since they have common denominators, I'm allowed to add the numerators?
Yeah.
Mhm.
That's all I did. I'm just making it into one. See how this is 2 terms and my answer is 1 term?
Yeah.
I know I'm going to have to combine terms somehow at some point. So I'm doing it by getting common denominators and then adding the numerator, adding them together. And what's sine squared plus cosine squared?
Sine squared plus cosine squared
Tangent
is 1.
squared.
It's 1, Micah.
Yeah, I get it now.
1 over sine, which is cosecant.
Which is cosecant. All right.
All right.
You guys want to try to find a couple more and try to stump me?
I will find a, let's see.
Or was that all of them that you had to do?
No, well, so far, but I'm gonna pull one from day 11.
All right. So also, while you're doing that, I would recommend that what you guys do is take these problems, watch this video again, go to YouTube or whatever, watch the video, pause the video when you see the problem, write it down on your piece of paper and try to do it yourself.
Mm.
And then scrub forward and see if you did it right, or watch it and see if you did it right. Because
Okay.
I make them look really easy because I've done these for years and years and I know where it's going. Oh, this is a different kind of problem.
Looks
I'm happy
complicated, so
I'm happy to do it, but it's a different kind of problem. Micah, before I start this, do you have any other trig identity problems you want me to work on?
Yeah, there were a couple on the day 2 homework that we skipped over.
You already posted them and I didn't do them yet?
I did not. Give me 1 second.
Okay, yeah, go ahead and put them on page 8.
Gotcha.
I'll come back to that in a minute. I want to stay in the same topic as long as we can.
yeah.
You find it, Micah?
Yeah, I'm entering them right now.
Okay. Here we go. All right. I'll do them one at a time, okay? On one on each page. So we have sine squared x minus sine to the 4th x, and they want that to equal cosine squared x minus cosine to the 4th x, right?
Mhm.
Yeah.
All right. So do you see what we're going to have to do? We're going to have to convert from sine to cosine.
Mhm.
Can you see that?
Yeah.
So remember what our formula is. Sine squared plus cosine squared equals 1. That's the formula we're going to probably be using quite a bit. So the first thing I'm going to do, however, is factor out a sine squared. Why? Because I know these kind of problems. Because that's going to give me 1 minus sine squared. Look familiar?
Mhm.
What's 1 minus sine squared?
1 minus sine squared is cosine squared.
It's cosine squared. That's right. So this equals sine squared x times cosine squared x. Got it?
Mhm.
Yeah.
So I converted this one to cosine squared. Now I want to convert this one to cosine squared. How do I do that?
It's gonna be 1 minus cosine squared.
Do you get that, Micah?
Yeah.
Sine squared, look at the formula down here. If I wanted, I could write sine squared equals 1 minus cosine squared,
Mhm.
right? So that's what I'm going to do. I'm going to rewrite sine squared as 1 minus cosine squared. Now I'm going to do what?
Foil.
Yeah, distribute.
Yeah.
And I get cosine squared x minus cosine to the 4th x.
You're done.
That's what I wanted all along. Good?
Mhm.
All right, this next one looks tricky. Looks a little tricky. Let's see if I can fit it on this page over here. So I've got cosecant x minus sine x all over sine x cosecant x, and that is going to supposedly equal cosecant x minus sine x.
I wish
All
that both
right.
the signs were positive. That would make it kind of easier because then you could just cancel out the signs.
Not, you
Well, if they're
couldn't
both
really
positive.
do that. Oh, wait a minute. This is almost too easy. Do you see what you can do?
Cancel out the cosecant.
What's this?
Wait.
What's cosecant, Micah?
Sine 1 over sine.
Yeah, and what's 1 over sine times sine?
Sine squared.
No.
Oh.
What's sine times 1 over sine? Not divided by 1 over sine. What's sine times 1 over sine?
Isn't it just 1?
It's just 1. Yeah, it's gone. And then I'm done. So this is sine x times 1 over sine x. And what happens to those two things right here?
You cancel.
They cancel out
They
the one.
cancel. And what's your answer?
Cosine
Oh,
minus sine.
And isn't that what they wanted?
Yeah.
wouldn't you
It
also have to do that
sure
on the
is.
top though, with the cosecant on the top, or no?
No, you
Oh.
can pick and choose. I want to keep this because it's, the
Oh.
answer still has one,
It's easy enough.
right? I'm just changing what needs to be changed for my benefit.
Okay.
Okay, good with those, Micah?
Yeah.
All right. Can I go back and help him with this real quick, and you can watch too?
Yeah.
Because we'll
We
be
haven't
doing
even
this.
gotten to this, but this is like the challenge problem for you.
Yeah. So this now, everything that you've been doing up to this point is really the point of everything is to be able to solve equations that have solving trig equations. That's really, remember how like algebra is all about, or calculus is all about solving problems.
Mhm.
So all the things that you've learned how to do up to this point have all been so that you can solve a problem like this. We have a problem and we want to find what values of x make this equation true. So here's what you're going to do. You're going to isolate this tangent x. So first I'm going to add 1 to both sides, right? And then I'm going to divide both sides by the square root of 3. So here's the question. Where does the tangent of x, for what x values, for what angles does the tangent of x equal the square 1 over the square root of 3? Do you remember your unit circle?
Is it
Yeah. It's 2 pi. Oh, wait.
Where is the tangent 1 over the square root of 3 between 0 and 2 pi?
That would
The
be
green is my tangent.
pi over 6?
Pi over 6 and
Yeah.
Negative. Oh,
right here. Third quadrant. Look in the third quadrant. 7 pi over 6. X equals pi over 6 and 7 pi over 6. Those are the two places that it equals positive 1 over root 3.
Oh,
And that's it.
okay.
why is this easier than like what we're doing right now?
It's not always going to be easier. That was an easy problem. They get harder.
Okay.
That was a simple solve equation.
Mm.
But honestly, the answer is because you're pretty good at understanding the unit circle. That's really why. because the unit circle is not hard for you. You see the value of the unit circle.
Mhm.
Like that unit circle there is like, it's golden, in my opinion. It's got so much information on it. And if you understand this, if you understand the unit circle, see how I've got triangles written in here? If you understand that, you really understand trigonometry pretty darn well, because the unit circle really kind of gives you a lot of it tells you a lot about trig.
Mhm.
So, but it gets trickier. Like for instance, they'll do stuff like I'll even make this trickier just to show you an example. The next thing they might say is, solve this equation. The square root of 3 equals tangent 2x minus 1 equals 0. Solve that equation. What did I just do to my problem? What did I change by putting a 2 into here?
That
So Micah, I'm showing you now a harder problem. It looks very similar, but it's a lot harder.
mhm.
But I'm going to try to explain it to you so you can understand it. You might not understand it yet, but hopefully you do. So here's what I changed. Do you remember that's the B?
Mhm.
And B has to do with what? What does B change? Remember how B had to do with the period?
Yeah.
So my period now is, instead of being pi, it's pi over 2, right?
Mhm.
Which means my period, remember how the tangent curve looked like this? Remember how it went like this?
Yeah.
And your period was normally pi. So it was pi over 2 and negative pi over 2. You remember that?
Mhm.
Well, now what did I just do to my period? Now I just made it, by making the period pi over 2, I just made this. This is my graph now. It's much steeper, and then it goes like this over here. And over here, it goes like this. So how many answers do I have? How many answers did I have for this problem up here when the period was pi? How many answers did I have?
2.
I had 2 answers, because look, where is the tangent equal to 1 over the square root of 3? Well, 1 over the square root of 3 is like this number, right? See, 1 over the square root of 3 is, yeah, it's like right here. This is 1 over the square root of 3. I'll draw it in yellow. This is roughly like 1 over the square root of 3, that horizontal line right there. And my red graph, so one of my answers was right here. See the red graph? But look at where they wanted me to find answers, between 0 and 2 pi, right? So between 0 and 2 pi really is this. On my original function was like this. There's pi over 2. And there's, let's see, I want to go another pi, would be 3 pi over 2. Right, so there's my next, whoops, that wasn't good. There's my tangent graph from this one up here, number 4. There's my tangent graph. I should have drawn it up there. And do you see that yellow line right there?
Mhm.
There are my 2 answers. That's pi over 6. And this one is 7 pi over 6. See that? Those were my 2 answers between 0 and 2 pi. But now what did I just do to the period when I put a little 2 in there? What did I do to this period?
You doubled it.
I halved it,
Even half.
which means I can fit, how many more little blue tangent things can I fit between 0 and 2 pi? I'm going to fit a lot more, right? Between 0 and 2 pi, which 2 pi is over here, I can fit a lot more. I can fit 4 of these things instead of just two red. See that I've got two red ones? I can fit 4 of the blue ones in there. So I'm not going to have just 2 answers. How many answers am I going to have?
4.
I'm going to have 4 answers now. So that's what the period did. It just gave me a lot more answers on that interval. Okay, so I know I went kind of a long way to explain that, but here's how you do this problem. You solve it essentially in the same way. So, but I'm going to call this thing right here, I'm going to call this u instead of calling it 2x and calling it x. I'm going to say let u equal 2x. So my solution really is u equals pi over 6 and 7 pi over 6, right? That's u. But remember, u is really 2x. So 2x equals pi over 6 and 7 pi over 6, which means, how do I solve for x? How do I get rid of the 2?
You divide by 2.
Good.
I divide by 2. So that means that x equals pi over not 6, but pi
12.
over 12 and 7 pi over 12. But that's just 2 of the answers. I have to find 2 more answers, right? Because there's going to be 2 more answers, because these 2 answers are not even, they're barely halfway around the circle. Pi over 12 is like right here, and 7 pi over 12 is like right here. Not even halfway around the circle yet. So I have to find, there's 2 more answers here and here somewhere, right? And I have to find those. And the way I find them is I add the period to each one of them. What was the period again?
Pi over 2.
Pi over 2. So now I'm going to take, for my other 2 answers, I'm going to add pi over 2, right? So my next answer is going to be pi over 12 plus pi over 2. And my other answer is going to be 7 pi over 12 plus pi over 2. So do the math on those. Pi over 2 is like 6 pi over 12, right? Oh, well, 6 pi over 12, I already have that. What's 6 pi over 12 plus pi over 12?
7 pi
7
over
pi
12.
over 12.
It's I already have that answer. But what's 7 pi over 12 plus 6? So this, I don't have to write that again. What's 7 pi over 12 plus 6 pi over 12?
13 pi over 12.
Good. So there's 13 pi over 12. And I better add it again now, right? Because I'm just going to keep adding the period until I get to over 2 pi. So what if I add another 6 pi over 12 to that?
19 pi over 12.
Then I got 19 pi over 12. Is 19 pi over 12 still in this range here? Is it still between 0 and 2 pi?
Yeah.
It is. So that is an answer still. What if I add another pi over 12 to that?
No.
It would be beyond that, so I don't have to do it. So your 4 answers are right here. Those 2 and those 2. You've got 4 answers. And again, that's because what I did is I took this period and I squeezed it. Now those graphs look like this. There's one of them. It's right there. Then another one is right here. Got it? Another one is right here. Another one is right here. So I've really got, look at all my answers. There's one of them. That was 1 pi over 12. There's another one that was 7 pi over 12. There's another one that was 13 pi over 12. And there was another one, 19 pi over 12. When I made my period, when I cut my period in half, that means I've got more answers in this range, 0 to 2 pi. I really wish I could see your faces so I could read whether or not you're understanding what I'm saying to you.
I'm starting to understand it.
Yeah, it's coming.
Okay, so I kind of over-explained it. I shouldn't have done that since you haven't even learned it from your teacher yet, but go back and watch it again, and I think it'll probably make sense. Like I said, I kind of over-explained it. I can't really see you to read whether you understand or not, but it seemed like you guys were getting it okay. The main point that I'm saying is, Micah, you said that seems really easy, and it was for that, but it becomes more complicated when they add things like a B here. That's when it becomes a lot more complicated. And that's why I kind of wanted to preview that for you. It's very simple if they don't have the B, it's much simpler. If they do have the B, you just have to think about how your period changed. And that's just going to change the number of answers, the amount of answers that you have. There's more answers.
Okay.
Okay.
All right.
But we'll leave it at that. Hopefully that helped. You guys seem like you have a pretty good grasp on this, but remember, don't think you do until you can do it yourself. So go back and practice that by yourself.